Welcome to this seminar. It's a great pleasure for me to be here in Kiev again after quite some time. Our topic today is circular economy. That's one of the buzzwords in Europe at the moment related to sustainable development, sustainable industry. Our topics today are the background of circular economy. We will talk about the legal framework. We will talk about the main elements. We will also talk about what makes circular economy so important. We will talk about resource consumption in Europe at present, waste generation in Europe at present, and why this is a strong motivation to go for a strong circular economy as a business model for the future. We will discuss a few strategies, how to move from the present linear economy to a more circular one. And I would like to focus then for pretty much of this morning on concrete examples. What we mean by talking about circular economy, what actual implementations could mean. I will show also a few examples where we were involved in developing more circular business models, and we can maybe share then the experience and extrapolate where these elements we will discuss today fit into your consultancy, where elements of circular economy can provide additional value for the companies you are working with at the moment. So, circular economy is not completely new. It's a concept that has been around actually for a while. The first papers on a circular economy were written in the 1960s. So good things take a while until they become mainstream thinking. And circular economy now definitely is mainstream thinking in Europe with UNIDO, with international organizations like the Ellen MacArthur Foundation, who is strongly pushing circular economy. This logo you probably know. It's the logo the European Commission is using for its circular economy package, which originally was written in 2014, then redrawn, then again published. There is a new version of this now, as of this year. We will run through the important elements. We will discuss what circular economy is composed of. The bigger picture now is what the European Commission calls the Green Deal, is the drive for sustainable industry, industry that is fully fit for the future, industry that does not that is prosperous, without causing environmental problems, without problems of depleting resources. All this is the background. Now, in this slide, we have the principles, the overarching principles, which are the foundation, the cornerstones of the circular economy model as the European Commission is using it. First cornerstone, we want to move from a linear economy to a circular one. Linear economy means to take resources from the environment, to process them into products which are used maybe once, maybe more frequently, hopefully, and then disposed of. This is linear economy, linear thinking. And what circular economy means now, to close the cycle, to keep resources in the cycle of economy, so that ideally We don't need additional resources to extract from this planet, and for sure not to discharge off too much waste, because there is simply too much waste. So the second principle, we want to turn waste into resources. Our production processes shall work in a way that they can work with waste as a resource instead of virgin raw materials. Which means that a waste must be composed in a way that it's a nutrient, actually. It cannot be toxic, it cannot be spoiled, it cannot be mixed. It needs to be fit to serve as a raw material. Third element, and a very important element in the concept of circular economy, is to empower consumers. Because from what we have been discussing, it becomes quite obvious. We are talking about products. Products are used by people. People who buy products take important decisions because they actually consciously or not so consciously decide what is done in production. So an informed consumer who selects rationally and who knows what problems are involved with the products he or she is using is an important element of the circular economy strategy. Pretty much the same means strong stakeholder engagement. A circular economy cannot work by one company in isolation only. Circular economy requires new partnerships of producers, of people maybe then renting, sharing the products, returning the products, reprocessing products, remanufacturing, repairing. So we need the whole society working on this model. We need a lot of interaction. We need a lot of cooperation. Important cornerstone. All this is clear from what I'm putting here as a vision, requires innovation, because some of the elements may exist in isolation, but they have not been combined yet. So we need to develop innovative solutions. At least we need to combine elements in an innovative way. And this also needs investment to a certain deal. European Commission is ready to support this. In Horizon 2020, a lot of money is put into research and development in this respect. In other grant schemes, loan schemes, there is a lot of support available for this. And then a thematic focus also exists, simply because of quantities of waste, simply because of urgency. We will explore this in detail. A thematic focus exists on certain sectors. Obviously, plastic is an important sector. Plastic waste, plastic littering, marine plastic, all this adds to the problem. Food is a problem, because a lot of food in the European Commission is wasted because of various reasons we can discuss maybe a little bit later on. Textiles are a problem because of their origin, because of the habit of consumers now to wear T-shirts once, twice, not even wash them anymore, but throwing them away. This is not sustainable. There needs to be a strategy. Construction materials, of course, because of the quantities. It's one of the biggest material streams. Electronic products, because of the elements which are required to make them, because of their provenience, because of their sometimes also toxic properties when disposing them in a not orderly way. So these are the principles. This is the background. These are the goals, and the goals are ambitious. If we run through these numbers, I see you putting an eagle's view on these numbers because they are actually ambitious. I think we all agree if the Commission puts a target that by 2030, we reuse, we recycle municipal waste by 65%. This is something we can imagine. Collect waste, separate it, reuse it, reprocess it, use it as a fuel, maybe waste to energy. But the second target is reusability, recyclability of packaging waste by 100%. So no waste from packaging in a generation, not even in 10 years. Landfilling maximum 10%, food waste minus 50%, no landfilling of recyclable waste, so paper, glass, minerals, metals, already by 2025. And all these combined with a cost-effective extended producer responsibility program, which means that pretty much of the material products which are provided are taken back by the producers and reprocessed, remanufactured, maybe repaired. So basically we could say the overarching goal is no waste to landfills within the next 10 years. This is an ambitious goal and it's a challenge, because this needs some innovative thinking on many stages of the product life cycle. We need to discuss materials, because not everything can be recycled. We need to discuss, of course, production processes. We need to discuss, before we discuss production processes, design, because stupid design of my cell phone can make it impossible to repair it easily. No nice thing like clipping things together or taking the battery out anymore. My battery is very difficult to change. I managed to, but it's not easy, so better design would help. Reprocessing, collecting, remanufacturing, recycling, all this needs to be looked at with an innovative eye. What would be an immediate benefit? The Commission estimates that almost 600,000 jobs could be generated all across the European Union by these activities, by opening up innovative fields of business, by having a lot of infrastructure, of course, for collecting, for separating, for repairing, for remanufacturing. These are the buzzwords now. So the targets are challenging. I mean, I mentioned in starting this presentation that the concept is not brand new. It has been around for a while, and when we discuss now relevant European legal acts related, linked to circular economy in a way, some of these directives, some of these regulations have been around for a while, for 10, 15 years. Some are brand new. Some are being re-evaluated at the moment for their effectiveness. The legal field is wide. If we look at the next 3-4 slides, this is just reminding us of what all is involved. At this stage, we will not go into details of these pieces of legislation. Important, of course, is the Waste Framework Directive, because it lays out all the terms, all the definitions, all the basic regulations. It strongly promotes the waste minimization hierarchy, so prevention is the first thing we should think of when talking about waste. It also has important aspects like the definition of end of waste, because this becomes important when we talk about recycling, when we talk about industrial ecology. Something that is waste in a company, I cannot simply sell or give to somebody else. There are rules, there are procedures. There needs to be contracts, because else I always could pretend, well, take your waste, do something good with it, and in the end it ends up anywhere. So this needs to be prevented, and this is all this is regulated in the Waste Framework Directive. Important cornerstone for circular economy is also the Eco-Design Directive. Ideally, there should be eco-design criteria when designing products. Right now, this is focusing pretty much on energy efficiency. So there are rules about minimum regulations for energy efficiency for all sorts of products, from heaters to household appliances. Many people in Austria were not really happy with the power limit for vacuum cleaners, because vacuum cleaners cannot have more than 2 kilowatts anymore. So according to the perception of not so informed consumers, they cannot work anymore because they don't generate noise anymore. So there are a lot of guidelines, lots of products where at least energy efficiency in the first stage has minimum requirements. There are plans now to extend this, not only to energy efficiency, but to materials which are used, to maintenance criteria, and so on. We have energy labeling regulation. This is this famous energy passport, which is stuck on refrigerators, dishwashers, and so on. And here we are with information passing to the client, to the consumer. Because how shall the consumer decide if he or she doesn't know about the product? This energy labeling is one step into these directions. There are others we will briefly touch. Waste Electric and Electronic Equipment Directive. Electronic waste is a problem, so it needs to be collected, disassembled, recycled, reused wherever possible. This Waste Electric Directive sets the framework how we deal with this. End-of-life vehicle directive is a directive which has been around for almost a decade, which is being re-evaluated at the moment, because it also has actually an ambitious goal. 95% of the materials of an average car should be recycled at the end of its useful life. 95%, that means pretty much everything. In order to make this possible, there is a huge databases. There is software available, which as of now 36 manufacturers are using. More than 120,000 production sites, all suppliers to the car makers, enter the material composition of all the parts which weigh more than 5 grams, which go into cars, so that it's documented what these parts are made of and how they can be recycled. This is being re-evaluated at the moment because there are doubts regarding the actual results regarding this directive. Batteries directive is not a showpiece of our legislation because it also regulates which materials can go into batteries. For example, no cadmium, no mercury, except with some exceptions like hearing aid batteries. And it's putting recycling targets. As of now, about 50% of batteries should be recycled. Also, this is being re-evaluated because at the moment it does not yet work. So, but for the future, there will be supporting mechanisms for this. We have the Energy Efficiency Directive. This is regulating energy audits, is giving minimum requirements for energy efficiency and so on. Energy performance of buildings directive obviously regulates minimum efficiency requirements for buildings. Goal is that in the next 10 years, all buildings, all new buildings in the European Commission are zero, net zero energy buildings, so that they don't consume but rather generate energy. Car leveling directive is something you probably have followed in the news over the last 3-4 years with Volkswagen, with BMW, with Daimler having problems in showing real emission values of their cars. Ideally, again, talking to the consumer, it should be public, it should be documented, it should be measured according to accepted standards. What are the emissions of cars, to provide a rational argument for consumers when selecting a car. Maybe not the biggest one, but the most efficient one, ideally. Directive on the restriction of hazardous substances in electrical and electronic equipment. This is again touching the point of cadmium, mercury, chromium, all these toxic substances, to keep them out as far as possible, because they are a hazard as they are, and they make recycling almost impossible. But when in recycling, in shredding, in milling, you mix these components, the whole mixture becomes useless. REACH, the big framework for assessing chemicals, registering chemicals, regulating the use of industrial chemicals. Hundreds of thousands of chemicals are used. There needs to be a register in any case, and there need to be some procedures, which chemicals we can use and which we should not use, or which we should use in a closed cycle or by trained people. There is a list of critical raw materials, because we will discuss in a minute. Not everything is available for the future as we are consuming it now. Talking about antimony, talking about beryllium, talking about cobalt. We have these materials for this generation, but we don't have it for the next 30 years or for the next 50 years. And this relates to other substances which we probably would not expect to be critical, like natural rubber is not there in abundance, like vanadium, like phosphorus. Even phosphorus rock is in high demand at the moment. So this list of critical raw materials, 27 at the moment and 56 candidates, shall give us orientation which materials to avoid, or at least use very carefully. What more do we have? We have directives related to concrete products, to safety, to technical criteria. We have one very important framework, which is the Industrial Emissions Directive, with the best available technologies defined and documented in brief notes. We have Public Procurement Directive, which shall support public procurement, which leads the way, which supports recycling, take-back, leasing activities, and so on. So, to make a long story short, we already have a lot in place. We actually have a lot of regulations which should direct us into the direction of a more circular economy. But as of now, it's not enough. All this, what has been around for the last 15 years, is showing the direction. But even the implementation of all of these is not yet bringing along an actual circular economy. And this is now why this package is there. This is now why there is a strong motivation to do even more. Why is this relevant also here in the Ukraine? Because this is not yet European Commission. The Ukraine has signed an association agreement, and in this agreement, in Annex 3 or something, you have a list, a timetable more or less, when the Ukraine should comply with which regulation, European regulation, and quite a few of them, which we have briefly discussed, which we have touched, are part of this timetable. Just to mention two, there is a construction products regulation, which to my knowledge was implemented in the Ukraine as well, laying out properties of products which are used in the construction sector, which is means some changes probably for the industry, but which on the other side open the European market for Ukrainian companies complying with this regulation. Also in packaging and packaging waste directive, to what I know, the Ukraine is preparing legislation to implement comparable legislation, which then will open up the European market for more Ukrainian companies. So to know this European legislation, to know the framework, to know the basic thinking, can help us also in making valid suggestions to companies when they think about exporting to Europe, when they want to prepare for a bigger market, which might be a quite lucrative market for many Ukrainian companies. Now, just to briefly show a very relevant document. This is actually part of European legislation. The so-called BREF notes you probably have come across for different sectors. Yes, doing the magic of having full screen. They are there for a variety of sectors. They are part of the Industrial Emissions Directive, which states that every industry above certain threshold values themselves has to check every 5 years whether they are applying best practices in terms of waste, in terms of emissions. So actually, this should go into environmental management, that the company checks whether they are applying best available technology or not. And in case they do not, they should have a plan how they plan to implement best available technology. And this is actually in Europe now part of permitting. The company cannot operate without a license which considers BREF notes. And what I just wanted to show is the table of contents of this, to make a long story short. Because these documents are also very good information for us as consultants. We do not see the number of pages here. This is the BREF note on waste treatment. It's about 800 pages, and it's basically an encyclopedia of waste treatment. What we have in there is a description of the sector, of the technologies used, and then coming to the conclusions, which is the most relevant part for our work. What is best available technology in the sector? And this starts with some general but conclusions, which in all cases is environmental management. So to have an organized system in place which regularly monitors emissions, waste, sets priorities, defines measures, and implements an action plan is one of the key conclusions. But then also more specifically, like now by environmental compartment, what is best available technology in order to reduce emissions to air? A waste treatment plant needs to have some treatment, which could be in some cases simply a cyclone, which in most cases should be a fabric filter, should include a scrubber, or at least water injection at the shredder to minimize dust emissions and so on. So running through this document, we quickly can get an overview of what is happening in the sector, what are the machines, what are the processes, what is causing emissions, what is causing waste, what is causing problems, noise and so on, and what are the recognized best practices. In many cases there are even supporting examples. Okay. There are even examples, there is more literature, there are case studies where you can find more information. Also, this is part of this legal framework. So to make a long story short, when we have questions regarding all of this, we have a small exercise then when I would, after that, ask you for the corresponding laws, regulations, bylaws and so on in Ukraine as a basis for discussion. Let's go a step back. Why are we taking all these efforts? What is making all the European politicians think, and what is the background that most of European industry actually does not object this anymore? Rather than objecting, rather than lobbying against these laws, now people are talking about how to implement that. Let's go this step back and let's explore the background in detail. Did you know that in the last 30 years, 40 years, the global extraction of materials has tripled? We are extracting now annually 65 billion tons of raw materials out of this planet annually. And this rate is expected to grow to more than 80 billion tons. Do you have an imagination how much material this is? Lots of material. And the bad thing is much of this becomes waste. Maybe another interesting thing to know, more than 90% of environmental problems that we have, like extinction of species, like problems with the environment, result from this extraction of materials or from the deposition of waste. And one number, and this is now the link to the circular economy initiative is only 12% of materials are actually recycled. Only 12% of materials used by industry are recycled materials. The rest is virgin materials. This has, of course, some reasons with practicality, with availability, with low prices of plastic raw material and so on, but only 10% is recycled. So right now, it's not a circular economy. Right now, it's linear. Make, take, throw away. And this cannot continue. It's a nice thing to have a car. Provides mobility. We can change our location in an instant. Just as a mental experiment, let's have a look at this chart. This chart shows what is the density of cars per person in different parts of this planet. So how many cars per person are there in the planet? You know by chance how many cars per person there are in Ukraine? In Austria, I know, it's 580 cars per 1,000 person. So two people have one car on average. In Romania, it's 280. In India, it's less than 10, 2-3 cars per 100 in this case person. Now, regions like India, or let's talk about China, sorry. Let's talk about China. Where's China here? Economically are growing. In terms of population, are growing. They also deserve a proper standard of living. What would that mean? Now, assuming that standard of living was defined by number of cars, what would it mean in terms of global economy, in terms of resource extraction, if 2 out of 1 Indian own a car? If 2 out of 1 Chinese, if 1 out of 2 Chinese owns a car, what would that mean in terms of numbers? And what would that mean if we look now into a nice car, BMW produced in Munich, assembled here, 5 Series, wonderful car, very fast, very reliable, easy to steer, really good on the road. What would that mean if 1 out in 2 people on this planet drive such cars? Car consists nowadays out of 8 to 10,000 components. To make these components, it takes materials and energy, of course. To produce 1 ton of steel takes 7 tons of materials, or coke, additives and so on. To produce 1 ton of aluminum takes 85. To produce 1 ton of copper, and there is a lot of electrics and electronics in a modern car, takes 500 tons. So to produce a car takes 80 to 100 tons of materials, minimum. To produce 1 car for 2 out of 1.3 billion Indians takes a lot of material. And even from these numbers and even from these very rough mental exercises, we can tell it cannot work like this. Global goods flows, good for the economy, but we do not have an imagination of how much materials actually are moved around and what the environmental impact is. Just to summarize this, we are expecting 82 billion tons of material consumption next year. And 10% out of these, and globally it's even less. Globally it's less than 9% of these materials are recycled materials. There are a few other observations we maybe should take into consideration. I'm just touching this now. This is looking into the European Commission and where the raw materials come from. And a lot of important materials like titanium, like platinum, like manganese and so on are imported. 100%. 100% import means totally dependent from what is going on the planet, without much chance of influencing this. This chart shows the outreach of resources, assuming now that we continue working as we are. Same economic model, same structure of industry. What does this chart tell us? It has some surprising messages. If we look here at the availability of zinc, for example, a metal which we need a lot for corrosion protection, for example, outreach is 20 years. So we definitely have to think about different models, how to deal with zinc, because it won't last. Very similar chromium. Gold is the same situation. Just a few examples. So with some materials, we have to start thinking, because we cannot continue like this, because the outreach simply is not there. Yeah, the bad message was only 10% of materials are recycled. Another bad message is about 10% of the materials which we are using are renewable ones. So the share of renewable material also until now is quite low. And this is also part of circular economy, to increase the share of renewable materials. Can be wood, can be bioplastics, can be fuels, whatever. But to increase this share, because at present it's not very large. Now, talking about recycling, just a little bit information, and then we will talk about the problems which are involved in recycling. These are European recycling rates given from Eurostat. We can debate the quality of the numbers and what they actually reflect, but as an order of magnitude, it's not so bad. On average, in the European Union, 40% of materials that can be easily recycled are actually recycled. That means 40% of plastic, glass, metals, paper and so on are actually recycled. Already these numbers show that we have quite a gap to fill, because here we are not talking about rocket science, but here we are talking about resource efficient and cleaner production. Separate waste, collect it separately, recycle substances like paper, like metals, plastic. Plastic we will discuss in a minute in more details, where some problems are. Now, one of the aspects of recycling is some products are not so easy to recycle anymore. If we look at our cell phones, how many materials, how many metals are contained in a single cell phone? Who is good in counting? How many do we have on this slide? Huh? with a, it should be a bit more than, it should be around 50, a little bit more than 40. Yeah. Now we have, in such a small device, we have 50 different metals and minerals. Is it easy to separate these, to recycle these materials? Not at all. Not at all. This is a huge challenge. Huge challenge, all these electronic devices. But even in a car, thinking about the components, how much electronic parts do we have in a car? Thinking about household appliances. All these things, even thinking about packaging material. Regular packaging for milk, for snacks, for meat. Is this simply one plastic like polyethylene, polypropylene? No, it's film consisting of 3 layers for oxygen impermeability to provide a longer shelf life, to avoid the negative impact of light and all these functional packaging is a huge problem in terms of recycling. Because all what we have combined nicely into that device, we have to separate again when we want to recycle it. This is another critical table from a strategic perspective. Periodic table of elements we are all familiar with. I know that you all have a solid background in chemistry. This is a special variation of the periodic table of elements because in this table the elements are color-coded according to recycling rate. So in blue we have the elements where we have recycling rates of about 50%. Then we have different shades of green and yellow. And in this reddish orange, we have elements which are recycled to less than 1%, which is a lot of them, and the most of them, yes. Just a little teaser. Here in red, upper left corner, what do we have here? Lithium, which is a fundamental cornerstone of all our mobile devices, batteries in cars. So far, there's very limited recycling of lithium only, which is actually a problem. And overall, 12% is recycled materials. Yeah, not touching these. Of course, if we have a global view of resource topics, we all know that some very important resources, like the cobalt for cell phone speakers and so on, comes from very critical regions where the extraction of these resources does not have a positive impact on the societies there. This was one aspect, availability of resources, recycling rates of resources. Another aspect are the properties of materials, which we also need to consider. And this was already part of the legislation which we discussed, because a big part of the legislation is simply restrictions for the use of chemicals, of elements. Some groups of elements we do not want in products. They are there, but we want to phase them out. And this involves right now 1,000 substances which are used on an industrial scale, but which we don't want. Most prominent ones should not be too much of a problem here in Ukraine anymore, but globally they are lead, if possible no lead, even in solders and so on, no cadmium, in paints, in corrosion protection, no chromium 6, although it's very nice surface and so on, but we should phase it out. But also some dyes. Some of these dyes are even still in Europe used in food because they are accepted because of the small quantities. DMF phthalates, these softeners in many plastics. Actually, we don't want them. We know they are a problem, but they need to be phased out. A big problem in recycling, because if we take back polypropylene, polyethylene with phthalates, we will contaminate the whole batch when we reprocess it, when we recycle it. I will show a few solutions companies have found to minimize this problem, and so on. We could continue this. This would be a specific, a dedicated topic to discuss chemicals, their properties, recommendations for replacement, because we are in Europe, we are very slow in this respect. The inertia is very, very big in this respect. So, as a intermediate summary, this economic model which we are using to take resources to make something and to dispose of it, that can't last. We know that, we have documented this, we have all the facts on the table, we need to act. There are limits which we observe already, which are quite obvious. Rising prices for materials, for energy is not always true. There is very high volatility because many people are speculating, inflating prices or lowering prices. So in metals, there are ups and downs. The general tendency is rising prices. Some materials we are running low. You might remember this chart on the outrage of materials, for example. There definitely is environmental damage. If you think about pictures which are on TV about mining in Central Africa or in South America, there definitely is environmental damage and damage on the societies there. We are doing our best in classical cleaner production to improve this by improving efficiency in production, in the industrial side. But this is definitely not enough. We need to find new models of material flows. And yeah, the small criticism to cleaner production, which comes from Professor Braungart, who had this keynote speech in Salzburg. By doing cleaner production, we are doing less bad. But this is not good enough. We really need to change patterns of production. We need to be efficient, and we need to manage industrial processes properly, but we also need to take the bird's eye view and to direct material flows on a global level by designing products properly, by selecting raw materials properly, by increasing product lifetime as much as possible. Needs to be discussed. There are some barriers in this respect, and by closing material cycles. This is the resume out of this. What does it mean on the level of an enterprise, of a production enterprise? These are numbers now from Germany. You probably know this because it has been readily published. Material cost of raw material, is about 40 to 50% of the total cost of a manufacturing company. taking European wages, taking European taxes as a reference. So in other parts of the world, probably there will be a bias to even higher share of material cost because wages are lower, as are taxes. So material cost actually is important for production industries, and if cost is volatile, if cost is increasing, this has an impact. The Small Business Act, that's another piece of European legislation which I did not mention in these first 3-4 slides on European legislation, estimates that better management of resources, and this is now already anticipating circular economy, could save for European industry around 600 billion euros annually. This is a lot. This is the gross domestic product of Austria, which could be saved from better material management. Now, what is the conclusion? Summarizing all of these, there definitely is a need to manage resources better. Starting points are, we have very low share in recycled materials, we have a very high share in new raw materials which we extract from the planet, and we have a very low share in biogenic materials, in renewable materials. So these would be the starting points for improvement. And improvement needs, and this is repeating now the story, needs to include the selection of raw materials, the design of products, production, distribution, consumption, the informed consumer, collection and recycling, to combine all these elements in a new economic model, which we call the circular economy. Definitions. This is a nice one because it has a narrative. It comes from the UK, so unfortunately we soon cannot call it a European definition anymore. Circular economy is an alternative, a different way combined from the existing economy, make, use, dispose, in which we keep resources in use as long as possible. However, we do this, we will discuss this, what are different strategies, extracting the maximum value from them, and then recover and regenerate product and materials at the end of their service life. So basically everything is allowed which decreases material intensity of GDP. So we want a strong economy, we want welfare, well-being for everybody, but with less resource extraction from the planet. So I think we can skip this one. This is how UNIDO pictures the strategies now, the approaches which we have, starting from the traditional production chain of materials, manufacturing, distribution, use, end of life, and then probably landfilling, remodeling this by reducing, replacing materials, more conscious selection of materials, biomaterials, by identifying the use, sharing things again. This is a little bit what our parents probably did, grandparents probably did. I remember in my family, cars were sort of collective property. Who needed the car would use the car, more or less. same with the drilling machine, same with the circular saw. These things constantly would move around. Little bit in this direction goes this model, sharing, using jointly. Of course, repair, reuse things so that we don't throw them away when the battery is too low to be recharged again, but that we change the battery, that we change the broken screen, and so on. Remanufacturing, like Caterpillar, for example, does. They buy back their old used Caterpillars. They extract all the parts which are defective, and they remanufacture a new machine. Because with this huge construction equipment, mining equipment, it would be much too expensive to scrap the whole machine. So they completely disassemble, change what is defective, and rebuild a basically new machine on the basis of the old. And then we have, as the classical part of circular economy, the recycling, the material recycling, the collecting of everything that can be recycled from paper, glass, plastic, and so on, shredding it and reusing it in the manufacturing of new raw materials. We have a few examples from the RECP network, and I would like to show with this slide that many of the things which we have been discussing now actually have been done already. You have done elements of this picture, but they hardly have been combined into a systematic approach to exploit all these strategies for an industry or for a company. Just an example here. UNIDO had a project in Pakistan to reduce hydrofluorocarbons, to phase out PCBs, so no PCBs in transformer oils and so on anymore. This would be replacing materials which we know are a problem. This next example comes from the ERP Green project from Belarus, from Komunarska, which is basically the same like Roshen. They take what they call sweet water, which is water which is rich in sugar from the first phase of cleaning, yeah, and collect it and reuse it when preparing the next batch. Why not? It's recycling. It's part of circular economy. Industrial ecology has its place in this picture, because recycling does not mean only I myself in my property on my site can reuse material or energy. Maybe the neighbor can, or an aviation company can. So the example here is heat supplied from a paper mill to a neighbor in an industrial park in Vietnam. From Tunisia comes an example where trimmings from clean fleshing in leather manufacturing are not thrown into a landfill, but processed to soap. Fat is extracted and soap is produced out of it. This is also replacing a raw material. This is also recycling. E-waste. Ethiopia was a big project to recycle e-waste properly, because there is even a European regulation now that e-waste and other hazardous waste cannot be exported beyond the territory of the European Commission, but must be processed here. And to process e-waste, how to do this properly, how to shred it, how to extract materials, was a project in Ethiopia. And I think the last one, yes, is very close. This is a chemical leasing example in Serbia. In Serbia, chemical leasing really took off to keep chemicals which otherwise would be problematic. We're talking about chlorinated solvents in this case, to keep them in a closed cycle and to keep ownership with the supplier, so that there is motivation to take good care of these chemicals. So what I want to say with this slide is, all these elements have been around, all these elements we master, we know. All this just needs to be combined, and we need to train ourselves so that in case we have an opportunity to apply all of these in a company, we are ready. We can identify the opportunity for circular economy. We can explain it, and maybe we can coach then in the implementation. This model now, this is the most complex or comprehensive model of a circular economy I know, was done by the Ellen MacArthur Foundation. Ellen MacArthur is one of the proponents of circular economy. She's a professional in sailing, in yachting. She was the first woman to sail single-handed across the Atlantic, and she held for a while the world record on this distance. And when she retired from sailing, she established her foundation, and they have really been the champions in this respect. And from them, this graph was done. This graph was done by them. And what does it show? It combines everything we have discussed so far today. We call it the butterfly of circular economy. It has a left wing and a right wing. The left wing is renewable resources. And the right wing is the realm of technical materials, of materials which are non-renewable. Because for the left wing and the right wing, we have different strategies. In the right wing, with the technical materials, the strategies we have discussed. We shall provide for a long, useful life. We shall recover the materials. We need to remanufacture. We need to recycle. In the renewable wing, strategy is a little bit different. In this wing, we want to use renewable resources, and we want to use everything that is waste as a nutrient again. So things might become waste, useful life might be not so long, but we must not contaminate renewable materials. They need to stay fruitful source for new materials. So and here we have then biochemical feedstock. We have elements like anaerobic digestion, like biogas production, compatibility with the biosphere. We have agriculture, we have farming, we have waste to food, and so on. And on the technical side, we have repair, we have refurbishing, we have reuse, we have identification of the use of products, we have recycling of materials as measures. So these picture of the butterfly combines all the possibilities for biogenic materials and for technical materials in terms of recycling, reusing and so on, closing all possible loops. Okay. To summarize everything what we discussed now in this first session, I want to show you a short video which is basically a statement of an Austrian print shop, how they received, how they understood the concept of a circular economy and what they do actually. What with them is mainly selecting printing colors so that their products then can be recycled in a paper mill without generating excessive hazardous waste. Because if I select inks which contain heavy metals or cyclic aromatic components, then pretty much of the dissolving pulp becomes waste. Let's have a look how they interpret circular economy and how they are planning to apply it.
Austria is world champion in paper recycling. Already 9 out of 10 newspapers and 9 out of 10 cardboard boxes are made from recycled paper. Which is great because it shows how many people here are ready to do something to protect the environment. What most people don't know, however, is that even in the recycling process, lots of resources are still lost. Because only the pulp can really be recycled, which is about 60% of the total volume. Up to 40%, mainly ink and filler material, is separated from the pulp and is left over after the recycling process as more or less poisonous sludge. This poses the question whether it's really environmentally friendly when, of any product, only 60% is really suited to recycling. Since the beginning of the industrial age, we produce things which end their lifespan on a rubbish dump. The motto is take, make, waste. But if more and more people use more and more products, then eventually we will run out of the raw materials needed to make new products. Already today, we consume more resources each year than the Earth can regenerate. So simply consume less? Unfortunately, no. In that way, we can at the most delay the depletion of our resources, not prevent it. We would then only be driving more slowly, but still in the wrong direction. It's about taking the right turning, because damaging behavior patterns do not become positive or useful if one does them less. But that is exactly what the issue is today, to design products so that they are useful and not merely less damaging. The most beautiful examples of this are provided by nature. A cherry tree produces endless blossoms. Once the cherry blossom season is over, the petals fall to the ground, where they do not become rubbish heaps, but flow back as nutriment into the cycle of nature. All resources remain intact and can be used again and again. The cradle-to-cradle design principle works exactly the same way. The goal is to lead more and more materials into cycles. For this, products must be conceived from the start in such a way that, at the end of their life cycles, they can flow back into biological or technical cycles. In the meantime, many products have been reinvented specifically for this, from televisions to sofa covers and carpets, to shampoo, t-shirts and toilet paper. New to this circle are cradle-to-cradle printing products, for which all constituent materials have been examined for environmental or health risk factors and, if necessary, replaced. And now, paper, inks and additional materials are manufactured so that complete recycling is finally possible. Now, not just the pulp can return to the cycle. In the future, even the sewage sludge may be used as fertilizer or for humus generation. And if this humus does not go straight onto a farmer's field, then maybe the trees will grow from it, which will then provide pulp for new paper. Cradle-to-cradle printing products could even be directly composted, and when burnt, the ash is good for the vegetable garden. With cradle-to-cradle, we can close the cycle. And now, with Googler, you too can print as nature would print. Off we go. Let's make an end to the destruction of resources. Let's begin the next printing revolution.
Okay. What do you think about such an basically advertisement? Because that's the way how the company is presenting itself now towards its clients. This is quite fresh thinking. And they are sort of anticipating and good information, yeah. And they are anticipating actually our challenge. And they are very careful. You saw in this picture this chemical guy in the laboratory. They are very carefully testing all the inks, all the materials they use. For materials which are a problem in recycling, then generating sludge, and they manage, or they have managed in a process of 3.5 or almost 4 years now to eliminate practically any inks that contain heavy metals or aromatic compounds. In a process, of course, that was involving the suppliers. Without the suppliers of inks, this would not have worked, because some of the color shades and so on are very difficult to produce, and it took them a while to get the right formulations and so on. But now they are there. Basically, they are products you can completely recycle. There are no objection to putting sludge from recycling their paper on the field as a fertilizer. And I agree, it's quite innovative thinking to use this as advertisement to show that we are prepared for the future and that we understand the challenges we are confronting. Okay, so we are back again. Now, I would like you to split into small groups, maybe groups of 3, and then we have a small exercise. Let's not spend too long, but let's use the worksheets which are around to think a little bit of about the situation which we have here in the Ukraine. What is the existing framework in legal terms for circular economy? Is the framework which we know in terms of laws, bylaws, regulations, regulations on the city level, financing conditions, is this system supporting the idea of circular economy? Does this system maybe contain already elements of circular economy, maybe in the Waste Act, maybe in one of the regulations or bylaws supporting the Waste Act? What do we know about this? Are there any laws, bylaws, regulations, and so on showing goals, strategies, responsible levels in administration and so on, which would support circular economy as we have learned about it? Are there technical regulations maybe demanding in the building code or in laws regulating air conditioning equipment and so on towards circular economy? Is there a separate collection system for waste? Is there something for industries on the household level, on the municipal level, in some municipalities supporting circular economy? Are there recycling companies? If I provide a truck full of paper, is there a paper mill in Ukraine which will recycle the paper? And if yes, for which materials would these apply? Apart from steel, of course. And are there deposits? Is there a system motivating consumers maybe to return bottles, to return packaging, to return household appliances? Are there some taxes? Maybe taxes on cars depending on fuel consumption, or just as a suggestion. Is there an eco-labeling scheme so that we transport information about energy efficiency, about materials, contents of products to the customer? And is there anything else supporting? Are there prominent NGOs? Are there government initiatives supporting this and so on? Let's spend 10 minutes on the exercise, and then let's briefly exchange our views and discuss what we have found. Let me thank you for your participation. I just show you what we have in Austria, just to summarize. We do have a Waste Management Act. We have strict definitions, what waste is hazardous, how it has to be labeled. Regular waste has to be separated, cannot be landfilled if there is a possibility for recycling. And basically for most of the things, there is a possibility. Waste that can be incinerated, that has a calorific value, needs to go to an incineration plant, cannot be landfilled. Technical regulations, we do have quite a few standards and so on, mostly borrowed from German definitions. I did not put them here. Separate collection system, we do have paper, packaging material, organic waste, glass, hazardous waste, construction waste. There are different systems, and the rule of extended producer liability applies. So for packaging waste, companies selling packaging on their products and so on have to pay to an association, and the association takes care of collecting mixed plastic waste and recycling it. Actually, pretty much of it goes to incineration, but ideally they should recycle it. Recyclers, we have 34 major companies which deal with everything practically. But I will show you in a minute what the business strategy of our biggest waste management company has become. Deposits, unlike Germany, we do not have, apart from bottles, glass bottles and so on. They carry a disposal. Taxes, we have in the form of fees for packaging materials, as I managed, and eco-labeling we do have for a variety of products, from detergents, from cosmetic articles, to textiles, to flooring material, construction materials, and so on, so that ideally the consumer can decide what he or she selects. This was just the idea of this exercise was to have a look into what is there, where the seed of circular economy maybe already is anchored, or what could be potential starting points if we think of the big picture. Let's go now up into more details. I started to mention when discussing this butterfly with the left wing of biomaterials and the right wing of technical materials, that two strategies apply, and this slide summarizes the strategies. Everything that is biological materials shall enter the biosphere again to build natural capital. That means compostation, that means anaerobic decomposition to generate biogas, to give a few examples. For the technical materials, the strategy applies of maintaining high quality, maintaining high value. Goods, products from technical materials shall be designed so that they can last, they can circulate, they can serve longer. And they do not mix into the biosphere, not in a landfill. These are the main strategies, and we will substantiate these strategies in a minute. A very important principle of circular economy is the idea of a functional service economy. The idea is, and it's sometimes difficult to translate into value, into something that provides revenue for a company. The fundamental idea is to perform a service and not to sell a product, like in chemical leasing. The idea is not to sell as many cars as possible, but to provide mobility. The idea is not to sell as much solvent as possible, but to provide the cleaning. So this service economy is a fundamental principle, and it has different applications then. All this leasing, renting, sharing, collecting, repairing, refurbishing, all this has pretty much the idea of increasing the functional value without adding more material. So this functional service economy principle is a really important one. What are now other principles? One principle is design out waste. By design, no waste, but lasting. Keep products and materials in use. This is long service life, repairing, and so on. Use renewable energy, because all this circularity, all this regeneration can only work with renewable energy, cannot work with fossil fuels, cannot work by causing carbon emissions, and regenerate natural systems so that the Earth, the planet, can live also. I will, in the end, show a few examples what we think about when we use this principle. UNIDO calls these strategies reduce, replace, as we have seen in the slide before. Reduce the consumption of raw materials, replace raw materials by less toxic ones, ideally by biogenic ones. The recycling is a strategy, of course, to close the loops, not to throw away things, but to collect them, to use them as raw material again. To repair things, to maintain the functionality of products, to remanufacture, basically more or less the same like repairing, but on a bigger scale. I mentioned the example of Caterpillar. This is more than repairing. This is really going over the whole machine and replacing all the worn-out parts and so on. It intensify, using the example of a car again, how much time of the day is a car actually moving? Because the function of a car is to move a person from A to B. How many hours a day is the average car moving somebody from A to B?
6 hours, 3 in the morning, 6 in the evening. Seems like a jam.
Because of the directions. Yeah. Now, the average statistics for Central Europe is that the car in a year moves maybe 12,000 kilometers at an average speed of 70 to 80 kilometers per hour. We can do the calculation. 12,000 by 80 is how many hours? Maybe 150 hours per year. How many hours are there in a year? 8,760 something, yeah? So is a car actually moving most of the time? It's not. It's standing in a parking lot, it's blocking space actually. So the idea of intensification is to share the use of a car in between more people, to use it actually, to use actually the function it can provide, and not to have it sitting around as a material thing only. And waste to energy is also an important building block, but instead of landfilling, at least the calorific value of materials we cannot use anymore is used. So circular economy is quite a broad concept, touches almost everything. It touches production, yes, that's where we are strong in, where we have a lot of experience also. It touches consumption patterns, how people actually are using products. This is why we have these questions of, are there deposits, is there information available, is there a municipal segregated waste collection system and so on. It involves trade as well, because trade has to support, for example, a system of returnable bottles. If the supermarket doesn't collect the bottles, the system is useless. So also this stakeholder in the system, the trade, needs to cooperate. And it touches all environmental aspects, basically. Examples now. The first example is definitely not circular economy. I just got this study 2 weeks ago. It's done by it was commissioned by the German Association of Manufacturing Companies, VDMA. Was done by a German consultancy, and they looked into global plastic consumption. And look what they found out. This not very complete cycle shows that globally, annually, about 360 million tons of virgin plastics is used. Most of it actually for packaging. 40% is for packaging, a little bit more than 20% is for construction, about 10% goes to manufacturing of cars. And the rest is all sorts of products, from household appliances to toys and so on. So 360 million tons enter the system every year. We know what goes in must come out. So where does this material go? The converting industry, process industry, is quite efficient actually. 385 tons, a million tons of these 390 are products. So the waste at this stage is not really impressive. But what happens to the products? In waste collection, documented globally, 170 million tons end up. 170 is not 380. Out of this gap, more or less, this is the improper disposal. This is what is called leakage, which means the numbers don't add up. And unknown plastic waste, this is just waste that ends up somewhere, is most probably, according to these numbers, 77 million tons, which is a lot, with products which are simply dissipated everywhere. From the rest, from the 173 million tons which are collected as waste, 72 go into managed landfills, and only about 50 go to energy recovery, to waste to energy plants. 50 million tons out of these almost 400 are recycled. They are collected, cleaned, regranulated. They become new raw material. 30 million tons are the product out of this recycling activity. So we end up with these 8 or 9% of raw material which is actually recycled for plastics. This is the status quo. This we do not want to continue. I think we all agree. Let's look at a few examples. This is something we are partly involved every now and then. This picture is taken from an Austrian supplier of detergents. And what is done there? In order to provide problems with the chemicals they sell, because they provide detergents, we have to work on the formulation of the chemicals and on the packaging. On the packaging, it's quite straightforward, like Googler, our print shop, with this nice animated presentation. We changed the inks. So complying with REACH, complying with all the other directives, no cadmium, no chromium, no azo compounds and so on. So inks is okay. With the substances which become detergents, it's a little bit more difficult because most of them contain conservants, which are strong microsites. We found different categories which are not so problematic, so this was replaced. And some additives are changed also to come up with products now where the packaging can be recycled and where the detergent itself is not harmful to the environment. So when it enters the wastewater and so on, in the end, the sludge is not contaminated and can become nutrient, like the Google video. So this is reduced chemicals, this is replacing chemicals. This is one of the first building blocks of circular economy we have learned about. This should be a principle which is widely applicable in industry. And this is something we can do also to support the selection of refrigerants, of cutting lubricants, of coolants, of biocides which are used in cooling towers and so on, to minimize toxic substances, to replace them by functional components which are not a problem for the environment. One example. Second example, in all this plastic recycling, we have seen it's not awfully effective. Huh? In the end, 8% of plastic is recycled. The rest ends up, some part of it in incineration, but most of it in landfills, controlled or uncontrolled. And some then in the sea and so on. We know all this from television. So, recycling. First example, on-site use. Of course, the closer I can keep the loop, the more effective. Why? Because there is less contamination. There is no effort needed for inverse logistics to take back. There is no danger of mixing. The closer I can keep the cycle for recycling, the better, the more efficient. This is plastic waste from a production company producing plastic for cars. They recycle these by, where's the picture, small in-house mills, small mills which you put aside the injection molding machines, and some 15, sometimes 20, sometimes 25% of the raw material you can replace by the material which you immediately recycle at the machine. We can discuss this in more details. I'm just keeping the story short, because this principle is then extended a little bit. These mills are available, another Austrian company, in a way that they can collect all the runners, gates, and so on immediately, mill them, but in case, because of the design of the mold or whatever, in case there is a surplus at the machine which cannot immediately be recycled, they immediately regranulate the material so that they can store it or sell it. Because at this stage, the material still is identical to the specifications of the raw material. It's not mixed, it's not contaminated, it's not nothing. We know exactly what we are handling with, which is the first precondition for meaningful recycling. We need to be able to characterize the material. It must not be contaminated. And it should be, of course, used as soon as possible by somebody who requires exactly the same material. This was applied in another company, also close to Salzburg. They are maybe 40 kilometers from where the conference was. Another example, again from the same region. This company is producing sheet plastic, I'm not saying which plastic exactly, which then goes to thermoforming for trims, for interior parts of cars. And after thermoforming with vacuum, the parts are cut to shape, which brings waste, cuttings, cut-offs. Now, this material, of course, is valuable for the supplier of this material, because the company knows exactly what magic salts they mixed into the material and so on. So for them it's a benefit if they get their material back, but only their material, not mixed with anything, not contaminated with anything. So what they do, they provide the logistics to regrind all the cut-offs, and then they use it in their production. This has been accepted very well, and this system is working very nicely. Now, of course, requiring the cooperation of the client, the company, organizing also the logistics, organizing that exactly their waste is recycled in the original company without any mixing, dissipation, and so on and so on. But this works. It took them a year to establish the system, but now it works. So from these cut-offs and so on, there is no waste anymore. Krauss-Maffei is probably known as the biggest producer worldwide of injection molding machines. Now, requirement has come, of course, that the supply of injection molding machines needs to be a little bit more complete in what he offers to the clients. So what Krauss-Maffei actually operates now is a business-to-business exchange for plastic waste. And it works great. So you enter their system, you declare what waste you have, and they find a client for your waste. Because this is like in the Google video, this is a way of marketing their product basically, because they not only sell the injection molding machines anymore, but they solve the problems, the resulting problems of the clients with the waste as well. And it requires some additional knowledge. It requires cooperation with people who can manage the software and who have the server and who can provide the security that nobody can hack the system and so on. But for them, this is really a benefit. And the overall system is circular economy because it reduces waste. A similar example here. This is a production company which produces all sorts of joints, connections and so on for furniture from plastic. They supply, for example, IKEA. So they are supplying a lot. They are producing millions of parts. And this is probably a surprise, they do not own 1 single kilogram of plastic material, because they supply to a major supplier to IKEA. They are sort of a second-tier supplier, and their client owns the material, and they only process it. The benefit for the supplier is, of course, he designs the material, he buys the material, which means in huge quantities, so the price is very good, and he keeps ownership of the material. So for sure this material is not contaminated. Like in the other example, the material comes back as it is, the waste from the injection molding comes back. They know it exactly, they know the properties, they have designed the materials, so they have designed it in a way that they can reprocess it and can add it to the virgin material. So this is a little bit a strange way of doing business, at least it was for me, because to have an injection molding company who does not buy a single kilogram of plastic is quite extraordinary. But this model has been very effective for this company and for their client, because the client has full control of the material cycle, and they have waste bins like an office building, because they do not have waste. They return everything to their client. Again, it needs the management, it needs the communication, it needs the more or less reverse logistics, which needs to be organized. So in this business model, additional elements enter now, which we have to control. Main thing is information, because if they run out of material, it's a huge damage if the machines cannot operate for a couple of hours even. An interesting model from Italy, Italians are always a little bit innovative, comes actually from irrigation. Iridec is an Italian company. They have as their motto, don't wait for the rain, we make it for you, by supplying these small hoses with holes. That's it basically. Now, the conventional business model would be they sell the hoses, and at the end of the useful life, the hoses are shredded and recycled. Now, in agriculture, you're using lots of different films, lots of containers and so on. So if you just wait for somebody to recycle, probably these hoses would be mixed with containers, with films and so on, leading to a mixture which is very difficult to separate and not very useful. So what was the conclusion of Iridec? They don't sell their hoses, but they get paid, like in chemical leasing, per square meter which they irrigate, and their technicians check the hoses regularly, and if they decide, well, they are worn out, we need to replace them, they collect their hoses and reprocess them. They shred them, they mill them, they process them into new pipes. Because they know their material. They know exactly what the formulation was, they know exactly what they need to add, what they can do with the material, what they cannot do. No experiments, they have full control of their material over the lifetime and beyond. So that's the idea behind this model of not selling the irrigation, but the rain more or less, to get paid per hectare irrigated land. And the wine is good. It's another example. We have lots of problems with water bottles. We don't, because this is a shining example. We have a jug full of water. But the usual way is you buy mineral water in the supermarket, 1 liter, 1.5 liters, and the bottle is nice PET, but you discard when it's empty. Now, this is of course against circular economy. This is against all the targets which the European Commission has announced, and the biggest manufacturers for mineral water, for carbonated drinks in Austria know that, of course. And as they are thinking strategically, they combined their efforts. So the biggest mineral water companies, Coca-Cola, which is big in Austria, and some producers of fruit juices, the biggest one again, and even a brewery. That's the first brewery and only brewery using PET bottles actually in Austria. They combined their efforts, they built a plant, they collect PET bottles, they installed a deposit system so that they get back clean PET bottles and not contaminated ones with any waste in it and so on. And then they recycle the PET. They cut it into flakes, and to qualify the PET for new bottles, they have UV irradiation so that the reprocessed material from hygienic perspective is 100% identical to new material. And that's what they do. This mineral water company at present uses 75% recycled PET in their bottles, and the plan is by the end of next year to have 100%. So it's possible. I know from Italy a few examples where they have packaging for food, like where you put cheese or all these antipasti and so on, which is made from PET also. For some big supermarket chains is 100% rebate already now. So this is possible, even such a waste, to 100% recycle it. It's possible, but it's still not practice. So the lesson from these examples would be, basically, you can recycle plastic, provided you're creative a little bit, you keep ownership of the material, you control the quality of the material, and you work on logistics and you work on cooperation. But basically, on an industrial level, you can recycle plastic, and on the post-consumer level, you can do it, but it's getting a little bit more difficult. Other examples, bottle to fiber, you probably know. The fleece jacket, which I wore yesterday, is actually recycled PET bottles. This is an example of the biggest European company doing that, Ponte Torto. They have it on their webpage, how the process works actually, how they collect the PET bottles, clean the PET, spin the fiber and produce the fleece then afterwards. These, in the meantime, most of the big sports equipment companies do. Schöffer does it, VD does it, Mammut does it. Most of these textiles, Patagonia pioneered it. Most of these textiles are actually recycled fibers. Just an example. Yeah. This was plastic. So plastic, in principle, we can recycle. We need to be creative. The constellation must be right, and so on, but we can develop business models. Small example from a company, last company in Austria, producing screws, nuts, and bolts. And one of their products is a special bolt, a special fixture for high voltage lines. And this is basically steel, which is bent into shape. Then it's pickled, and then it's hot dip zinced. And for the company, the problem was always the spent acids. So what could one do about it? This was a process of a year or a little bit more, 1.5 years. With the supplier of the bolts, we had a word, and after working a little bit on their process, all the conserving oil which was used after the bending could be eliminated basically by improving the logistics, so that quickly after bending the parts are delivered to sinking. So no degreasing, because there is no oil anymore. So first process eliminated. Second step, optimization of the pickling acid to have proper concentration to provide for a long, durable life. Optimization of the rinsing, and then, and this is the actually interesting part, a contract with the supplier of the acid, so that they now take back the acid, like in chemical leasing, but it's not really a leasing contract. They sell the acid and buy back, because they want to have a step where they can interfere in case the quality is too bad. But basically, there is no waste anymore. And the supplier of the hydrochloric acid manufactures ferric chloride, which they then sell for wastewater treatment. So basically, they closed this cycle completely. No waste in these steps. We are taking very good care of animals. If you look at the supermarket, the different varieties of animal food, of cat food you can buy. We had a contract for one of the biggest Austrian companies producing pet food, dry pet food. And for me, it was a surprise that they produce some 40 varieties of products. So 40 different pieces, even with different colors, different shapes, and so on. And when you have so many different products, you need to clean the machines because they're basically extruders in between different products. And cleaning always produces a mixed waste in a way. So, and this is quite a dear product. It's quite an extensive product. So, at some point, the question was, well, to send this away as a waste is a waste. Let's think about recycling. And of course, the technology is there. This machine is basically a laser which identifies the color of the small bits, and then we have a system of nozzles, compressed air nozzles, which transport the individual waste into different containers, fully separating waste. This machine was expensive. The machine was 150,000 euros, but in this plant it paid back in 4 months. And it avoided a lot of waste, and this technology is applicable to a lot of different things. You can separate different glass colors, you can separate different stones, you can separate some metals even. Okay, so recycling. This is getting now a little bit into what we actually would call industrial ecology, but it's also part of circular ecology, but it means, because it means basically recycling, in this example heat. What we have here is another print shop. This is a print shop in Serbia actually, and they use a lot of solvents which evaporate. So they have to have an oxidization step of the exhaust gas, which generates heat. Heat recovery is good. This recovers part of the heat. You can use it in winter and so on, but not during the summer. So what can you do? You can use an absorption heat pump, which transforms the heat to cold actually, and cold you need in the print shop because you need to air condition the whole print shop. So basically they close the whole cycle, and energetically with the heat they need for oxidization of the exhaust gas, they cool their process. Similar example here. This is one of the biggest milk cow installations, again in Serbia. And cows, lot of cows means a lot of manure. Lot of manure becomes a problem if you don't have a lot of land where you can apply the manure. So the suggestion was to install biogas plant. This worked very nicely, but then what is the next problem? What to do with the biogas? Okay, internal combustion engine to generate electricity is a clear-cut technology, was installed. What is the next level of problems? If I have an internal combustion engine, I have a lot of heat. So they ended up with a lot of waste heat until they installed a dryer, because they also had a vegetable farm. So what they do now is, with the waste heat of the cow manure, they dry spices, herbs and so on, and sell them as a product. So all the energy content actually of the manure is used well, and the result, the retentate of the biogas plant, is then fertilizer, which can be sold to other farmers. What else do we have here? Yeah, from these observations or from these individual examples, what is the future of waste management? Let the chairman of the biggest Austrian waste management company speak. Saubermacher is has become an enterprise with more than 4 billion euros revenues. And what is their strategy? How are they advertising themselves? It's the biggest waste management company in Austria. Their advertisement is zero waste, 100% circular. And how they do it is by recycling. They moved away from a simple waste transport company to a company which does waste analysis for their clients. So they send somebody looking at your waste containers, checking what actually are the constituents of your waste. They make a waste management plan for you. They even provide the containers which they put on your site. They provide a waste manager who oversees your facilities then, and they have shares in a plant which prepares waste so that it can be used as fuel in a cement mill. So what they actually do is they know exactly what the waste of their clients is. They pick the interesting parts of the waste and they sell these to cement kilns. This is the business model of our biggest waste management company. And their advertisement is zero waste. Now, I mentioned earlier this idea of functional service. The next examples are illustrating how this can work in practice. I'm sure that you have comparable companies here in Ukraine. It would be a complete surprise if you don't. DCM is an Austrian company, not far from the place where we have the office, but it has become an international player in the meantime with more than 4,000 employees globally. And their employees are not on site in Austria, but they are working on site with the clients. The clients are metal manufacturing companies, like producing parts, cogs, axles, wheels for car manufacturers. And DCM is supplying the tools, but they don't sell the tools. They give the tools, they sell the number of pieces which are cut or grounded or honed, and they take back the tools and they reprocess or replace the tools. Completely worn tools are replaced, and tools that can be repaired are repaired and then supplied again. And their people are embedded more or less with the production companies and check and monitor and optimize the process and assist the client in better manufacturing. It's a huge business in this respect. Let me just, another company controlling the market in waste cooking oil in Austria. If you want to start a business on waste cooking oil, no chance anymore. The market is all contracted. They collect all the waste cooking oil and reprocess it to biodiesel. And This, to my knowledge, is the only way of producing biodiesel that ecologically also makes sense when you use waste cooking oil and do not import palm oil from the Philippines. Soda-free manufacturing. Now, this is starting only. This is a company in Vienna, but employing already almost 100 people. And what they do is to collect washing machines which do not work anymore or which people do not want anymore, repair them and sell them again. This has become a quite profitable business model. They specialize, of course, on some brands, like Miele, for example, like Bauknecht, and not so much on Gorenje or so, because they know the machines, they have the spare parts, they know what becomes defective, and they know how to repair the machines. They give you 3 years warranties on the repaired machine. So this is quite good. This is avoiding a lot of waste. These repair cafes probably also have in Kiev that people meet with electronic appliances which do not work anymore and try to fix them and so on. This has become sort of a trend with us. In Graz, we had some 40 repair cafes the last year, because for some people it's a nice hobby and it's a nice distraction. It has become fashionable to fix cell phones, mixers, heaters and so on. Yeah, these are 2 examples for products. This is a German startup company which produces LEDs which can be repaired when they burn out after 50,000 hours or so. You can dismantle them, you can change the LED. It's a nice idea. And which would identify the use, of course, because like this, the LED, the luminaire basically can live forever. And this you for sure know, the Fairphone, which is a Dutch invention, is a cell phone where all the materials are acquired to fair conditions at fair prices, which has a modular design so that you can change the battery, change the backside, the front cover easily with tools which they supply already with the original Fairphone, where you don't destroy clips or so when you try to disassemble, where you don't have to heat glue to open the phone and so on. Everything is designed in a way so that it's repairable even by an amateur like myself. So there are, I wouldn't say it's a trend, but this is coming more and more, that designers design products in a way that you actually can increase the useful life by repairing them quite easily. Yeah, we talked about vintage clothing. With the young people of around 20 or so, this has in Austria become a fashion. In Graz, which is a small city of 250,000, we have 4 such shops, and in Vienna there are about 20. Really selling used clothing, of course better quality, sometimes branded, sometimes really. In Vienna there are 2 shops who really sell haute couture textiles, which people have disposed of and given away. to be reused. So there is, amongst some people, this repairing, reusing, and so on is becoming a trend. So before we break, just 2-3 more examples. This is a company reprocessing waste into new goods. Even like it or not, they, for example, from the basement of an office chair, made a luminaire, which sold at a little bit more than 1,000 euros because it won an award for sustainable design or so. So some approaches are there into this direction. This has become a quite solid market, actually. You will find 5 or 6 major companies who refurbish laptops. Mine also is a refurbished one. It has been working for more than 3 years now after refurbishment. They give 3 years warranty on their equipment. Simply a way of prolonging lifetime. This is a case study which we will do in the afternoon. Big problem with all big public events. Single-use plastic cups from beer, Coke, whatever one prefers. The alternative, which is also linking us to public procurement, because cities like Vienna, for example, make it obligatory that all the restaurants do not use single-use plastic cups anymore, but returnable plastic cups. So on Donauinselfest, for example, you will only find returnable plastic cups like these ones, and they afterwards are collected. Again, they charge a deposit so that they make sure that not too many end up as souvenirs somewhere, but they are returned. They are washed in a washing machine and then stocked for the next event. Is a profitable business model. In one of these, that's why I have the pictures, we were involved also in defining and negotiating all the elements, because this model again requires the cooperation of different actors, in this case even of different companies. Because there is one company providing the full service. So if I'm a restaurant owner, if I have a big party, I call these guys, make a contract with them. Well, I need in 2 days 5,000 cups. And this company organizes that they get the cups, they keep a stock of cups, whatever they need, any balance or so they buy. Then they need a logistic company, which is not the same company, but a logistics company which can make good use of their trucks, because they transport also other stuff, and a company washing the cups afterwards properly in a machine with minimum consumption of water, less than 100 milliliters of water per cup, almost without detergent, just 0.5% caustic soda. That's it, if you do it properly. Basically the whole organization is done by one company. Is a business model which is profitable for everyone. I have the numbers, I could demonstrate this. Apart from the producer of single-use plastic, this guy does not make money anymore here. Yeah, this is a chemical leasing example from Serbia. We can discuss the approach also. Probably you could discuss it better. This is a chlorinated solvent which a producer of bearing uses. in cleaning the parts. And Pero, which is SafeChem, which is a Dow company actually, they manage the solvent, which means they own the still, which redistills the solvent for reuse, because of course the perchloroethylene needs to be kept in a closed system and needs to be recycled. So again, a business model where material consumption is reduced, but requiring the cooperation of the client, of the supplier of the chemicals, and some machinery which the supplier brought in. Yeah, car sharing, this example which we keep reiterating in a practical example. When I go to the west of Austria, which is Vorarlberg, which on the road I go via Munich, and which is about 700 kilometers, I stopped using my private car. I go with overnight train, and when I'm there, I take a car from a car sharing company, which in this case is an electric car, and use it there. This car is basically operating all the time. Even at night you have to be on time, because the next person is already waiting for the car. And the trick is how to keep it charged, because it's a Renault with a battery which is not so good. But to intensify the use of the car. Okay, welcome to the second part of this. We are starting from where we stopped in the morning before lunch. We had a look at a few case studies, basically from all over. And we'll continue now with a brief video of an innovative Dutch bank summarizing the ideas, basically, which we already discussed, plus adding the potential of financing, so that all the stakeholders which we need for innovative solutions, when all this lending, leasing, intensity increasing is involved, a financing partner comes in. So.
In today's market, it's no longer enough to create and sell state-of-the-art equipment and technology. Suppliers need to find better ways to move products through their distribution channels. And businesses need an easier path to acquire equipment and technology so they can focus on growth. Well, what if financing programs could meet both demands? With DLL, they can. Our commercial finance, retail finance, and used equipment finance solutions create incremental value and revenue streams for suppliers and their customers at all stages of the asset acquisition process. Whether you're focused on moving products more efficiently to market, streamlining the sales process to increase business opportunities, or seeking to acquire assets to meet growth objectives without depleting cash flow, DLL's team of industry experts can tailor a financial program to meet your specific needs. Even better, each stage of the sales process is made easier, better, and faster through DLL's innovative digital solutions, including self-service portals, mobile applications, electronic signature, and documentation. And as consumer preference shifts towards pay-per-use concepts, DLL's usage-based finance solutions enable suppliers to meet those changing demands while driving incremental services revenue and customer retention. Pay-per-use models also present an opportunity to gather insights on more efficient usage methods or offer upgrade suggestions to lower total costs. Usage-based concepts support the circular economy by promoting the sustainable use of equipment. With more than 50 years of experience, businesses benefit from DLL's expertise and our commitment to evolving with them in times of prosperity and adversity. We understand the unique needs of our partners around the world and offer proven solutions to help businesses thrive.
Okay, this was this statement of a bank. Bit unusual advertisement. They don't want to sell a loan or a credit line, but they offer to enter into the business life of a company as a partner to finance pay-per-use or pay-per-hectare, what was shown in the video solutions. This is quite innovative, isn't it? This is actually the biggest European bank now financing such activities. They focused, they specialized in this. Yeah, let's continue with a brief exercise to summarize the morning. This is the exercise. You again have worksheets in front of you. We have here 6 different examples which were presented in the morning. We will briefly run through them, and you in the groups, please select then which strategy or which practice was chosen in this solution. So according to what we discussed, whether the example was more focused on reducing, replacing some material, whether it was more on recycling, whether it was on repairing, reusing, on remanufacturing, or in identification of product use. Okay, so you simply make your mark wherever you think it's appropriate, and maybe add, because I was discussing already with Andre, you do have quite a lot comparable cases here in Ukraine, like the tools reprocessing, tools remanufacturing you mentioned, or Vitali repairing an LED. So there will be examples from your experience. So please note them in the last column of your worksheet. So the examples, and let's remember them together. Elimination of heavy metals from printing inks. This was Googler, the print shop. They took out all the toxic components which kept the sludge from wastewater treatment from serving as a fertilizer. Polymor, that was Kraus Maffei, the big supplier of injection molding machines, and their model was a waste exchange, a plastic waste exchange basically. Then we had besides the press mills, milling the waste from injection molding and recycling it to the material hopper. Then we had this repairing company with the washing machines, fixing the laundry machines. We had the collection of waste cooking oil, transesterification, biodiesel production, the take-back system for used irrigation hoses from this Italian company, from Iritech, servicing wine farmers, and tools management, this TCM, this company supplying tools to manufacture of parts for the car industry. Now, according to your assessment, according to your evaluation, which strategy applies to the corresponding example, and can you find similar examples here in Ukraine from your experience, from working with the companies, from working in assessments? From these examples, I think we can work on. The idea basically is just to get into this thinking, and when we see a problem in the future, always put the question like this: can we replace something here? Can we recycle? Can we replace to facilitate recycling? Can we repair, reuse, reform, manufacture? Can we identify the use? Here the point is to generate ideas, potential options, opportunities, like in resource efficiency and cleaner production. The assessment, the building of a concrete business model out of this comes later. We have another example in the end where we will put all this together to elaborate an idea into a functioning business model. This stage, it's about the idea. Okay, so this is just the boxes I ticked. Let's close this. Let's continue from here. Now, we have lots of opportunities. How do we find a starting point? Can we systematically work applying circular economy to identify a meaningful starting point? When we have an existing business model, where should we start looking for improvement? Where should we start asking whether our practices can be applied? And in the circular economy, you saw a few suggestions. The idea is to use life cycle assessment to understand the full life cycle of a product, to do an inventory of material energy flows, to assess it, and to select the area with the highest impact and to start from working there. This is the idea of product life cycle or process life cycle. And for this, I invite you to join the life cycle assessment network. You have the webpage then in the materials. It's a European-wide network where experts exchange life cycle methodologies, because there are quite a few, and what is more important, data. Data on everything. How much energy does it take to produce 1 kilogram of polycarbonate, to how much diesel does the average truck consume, to what are the emissions from the production of 1 kilogram aluminum. All this is there. We are doing now an example. Let me explain this first. What a life cycle analysis is more or less clear. We note the steps of a life cycle from the extraction of the materials over production, the use phase, and the recycling or landfilling. Then we make an inventory of the material flows, which is called the inventory. And then we do the evaluation with the data which we extract from a database or so. We translate the material and energy flow into emissions, and the emissions we summarize and assess, evaluate. For this there are standards, the ISO 1440 and 4044. And before we do the exercise, we have a nice video explaining, a company explaining, Gore-Tex, which you all are familiar with, why they are doing it, life cycle analysis and how they do it.
Why is Gore doing a life cycle assessment? Gore's founders, Bill and Vive Gore, taught us the importance of acting responsibly. Based on this, quality has always been a crucial element of our product strategy, along with durability and performance. Over the years, we've also done a lot to reduce our product's environmental impact. A major milestone in our journey was the introduction of Life Cycle Assessment, or LCA, in 1992. This scientific method gives us the opportunity to fully understand our product's environmental impact. By looking at the big picture, we can continue to act deliberately and responsibly. What is a life cycle assessment? Life cycle assessment, or LCA, is an internationally recognized standard and currently the best method available to scientifically measure the environmental impact of a product. The great thing is, LCA doesn't consider just one aspect. It looks at the bigger picture. By analyzing the whole life cycle of a product, from raw material extraction to disposal, and by looking at different factors like energy consumption, carbon emissions, and water pollution, for example, in each stage. The final LCA report summarizes the various impacts of the product and translates them into 20 different indicators. That holistic view from cradle to grave enables us to identify how to minimize the product's impact. But what does that mean exactly? Let's take the indicator global warming potential, also referred to as carbon emissions, as an example. In 2013, we measured the environmental impact of a typical pair of Gore-Tex hiking boots. The results show that raw materials and distribution have the greatest impact. 77.2% of the global warming potential measured in CO2 equivalent occurs at the beginning of the boot's life cycle, whereas disposal contributes less than 2%. This means that the less often a new pair of boots needs to be produced, the smaller the impact on the environment. In the LCA, we assumed that a pair of typical Gore-Tex hiking boots was worn for 3.5 years. That comes with a carbon footprint of 27.1 kilograms CO2 equivalent, which is comparable to the environmental impact of driving a mid-sized car that consumes 7.5 liters fuel per 100 kilometers for 100 kilometers. What if you need to buy 2 less durable pairs in this period because they fail early? This would result in carbon emissions of 52.4 kilograms CO2 equivalent to stay dry and comfortable during the same period of 3.5 years. Transferred to our car, you'd cause an environmental impact of 190 kilometers instead of 100. If 1 million consumers chose to buy a more durable pair of hiking boots half as often, this could save the equivalent of circling the globe 2.3 times with that same car. What do we learn from this? Our waterproof, windproof, and breathable fabrics play an important role in the environmental impact of Gore-Tex products. Since the production and distribution are the most critical stages, we need to provide comfort and protection for a long time. Because the less often you need to buy a new piece, the smaller its effect on the environment will be. Gore is taking its commitment to continually decrease the environmental impact of its products seriously. Using and promoting LCA as an important instrument to develop better sustainability practices for the apparel and footwear industry is part of that. We develop product innovations and performance test methods like the RAIN or the walking simulator test. And we cooperate closely with our partners to make pieces that people can use and love for a long time. Moreover, we are committed to several sustainability initiatives in the apparel and footwear industry to make our products more eco-friendly. Another important factor for the product's impact is you. Switch to buying products that last long and buy fewer of them. Wash and care your pieces according to their official recommendations to ensure that they function and last longer. As you can see, we can continuously decrease our environmental impact in order to contribute to a cleaner and more sustainable world. But we can only do this together.
Let me finish this sentence. What do you think about this advertisement? Because this actually is an advertisement.
We have to buy expensive.
Good walking boots is important. Now, but I think the key elements of the methodology, they presented quite clearly. The choice of an indicator, in this case, carbon dioxide emissions, which is balanced over the whole life cycle, and then to draw a conclusion out of comparing different scenarios was nicely presented. Yeah, what hiking boots are you going to buy now? You already gave the answer, yes? Austrian, there is nobody left in Austria. You have to go to Italy. Yes. So let's again apply this. We have a small case study here where we do life cycle analysis. And the idea is to assess the useful life of a single-use cup from PET, so a transparent one. This is already advanced. This is paper. This is waxed paper or with a film. We are looking into PET cups, single-use drinking cups. We have here, and you have it in front of you, a brief condensed problem statement. Our task is to do a simplified life cycle analysis for a single-use PET plastic cup. The cup is used at soccer games or music festivals. So the point of this cup actually is that it does not last long, and you can throw it, but it will have no impact. You cannot hurt anybody with the cup. That's the main purpose of this cup. One cup weighs 15 grams, so it can hold half a liter of beer or Coke. The PET, now how is the cup made? The PET is bought as a thin film on coils. In the factory, the cups are thermoformed, which basically means the cups are pressed out of the film with a tool, then cut. There is some off-cut, like in the example we have seen before. This is returned to the manufacturer of the film. So production waste at this stage is not really our concern. The factory consumes 500 megajoules per cup to produce one cup. So the thermoforming machine and the conveyors and the lights and so on in total consume 500 megajoules per cup. At the end of the event, when the game is over, when the band has stopped playing the music, all the cups are collected and put in bags and landfilled. So now our task, let's use the attached worksheet below, and attached to the problem statement is a worksheet for an inventory analysis. So for the material inventory and energy inventory of the life cycle of a single-use plastic cup. List all the materials involved in the production of the cup, in the use of the cup, in the disposal of the cup, and the energy flows which you can identify. Need not be complete, just out of our discussion now. And then focus on energy flows. So our environmental indicator, which we will be using, is energy, total energy over the life cycle. There is a template for a chart, show at which stage of the life cycle how much energy is used and how the distribution is and what we can learn from this distribution. You will need some additional data. We know the embedded energy of PET. So to arrive at the material, we need 72 megajoules per kilogram, per ton, sorry. The energy production from cup is 0.5 megajoules. We know that the garbage will be collected after the event by a truck. Truck has 20 tons carrying capacity, consumes 40 liters of diesel per 100 kilometers because it will have to stop frequently and move on again and so on and so on. The distance to the landfill, we assume, is 50 kilometers. And So let's do this inventory in the first at the first stage. Let's discuss it, and then let's build a second scenario. And the second scenario is now the alternative is a returnable cup. It's made from polypropylene, so it will not break whether we throw it or sit on it, or so we cannot turn it into something dangerous. It's made from polypropylene and it weighs 100 grams, so it's heavier. However, it lasts, and we want it back. Therefore, we collect a deposit. The return rate is very high, it's almost 100%. After collection, the cups are transported by truck to a washing facility. There, the cups are washed in a fully automatized washing unit, which consumes 0.1 liter of water per cup and 0.5% caustic soda, so a slight touch of caustic soda. Again, we have the embedded energy of polypropylene, we know the weight. The cup can be returned like a recyclable bottle 100 times to 150 times. I've witnessed that the cup really stands this number of washing. Energy of production, we know, is 3 megajoules, is more than with a PET cup because it's more material. Water consumption, embedded energy in the caustic soda we have, distance we again have. So let's use this worksheet, which basically shows us the 5 stages of the life cycle: the raw material, production, the use, recycling, disposal. It's 4 only, sorry. And let's collect from our problem statement what are the quantities of materials, how much energy is involved. Let's use our fantasy, imagination a little bit. What are waste and emissions in the individual stage? Let's build a diagram. Where do we consume how much energy during raw materials extraction, during production, during use, during recycling, disposal? And let's then compare this to our alternative, to the returnable cup. Is it better? Is it not better? Is it much better? Just qualitatively, more or less. So basically here, the idea was to mark more or less, to prepare the last conclusion. Where does energy go in percents of the total energy? And most of the total energy with a single-use cup definitely goes into the raw materials, something into production, and not so much in use and disposal. And with the returnable cup, the distribution is a little bit biased also to the actual return to washing. So we definitely have to have a good model for logistics. These are then just the numbers. Let's make a long story short. Now, just 2 excursions, and then we will zoom into the business modeling for circular economy. One important aspect in all this circular economy is energy, because I can have a lot of recycling, but still for recycling I will need energy. And ideally, of course, this energy should be green, should be renewable energy. And this is now not so much my part, but this is your part, your research. At what cost, at what benefit is renewable energy available in the Ukraine? Are there any feed-in tariffs? Are there legal recommendations or models, or are the energy producing companies offering some incentives to support green energy, feed-in tariff? This would be my question to you. There is. I know that there are quite a few big biogas plants, especially in the agricultural areas. Are there feed-in tariffs for photovoltaic, for energy, solar energy also? Okay, so these might be options, because actually we have biogas, solar energy, wind, and we have waste-to-energy incineration as options. These are just a few pictures. This is one of the bigger biogas plants close to the area where I come from. They use all sorts of waste from meat processing, from food processing also to generate biogas and to generate electricity out of it. The solar power, this is actually a company producing luminaires. They are one of the bigger ones in Europe, in the western part of Austria, and they decided last year to invest into a solar power plants. They put almost 4,000 square meters of PV panels on their roof, but they got a special deal from the regional electricity board. So for them it paid back in 6 years, which is exceptional. It's not the rule. Usual payback is still 12 years, 14 years or so with us, and probably similar in Ukraine. But it's a lasting investment, very low in maintenance. So if you have the money, or if you have somebody who wants to invest the money, this can be a good option. Wind power is a topic in Ukraine, yeah. In Austria it is, yeah. Yeah. Good. And this is waste to energy. This is completing the business model of Saubermacher. You remember the slide with the CEO who announces his waste management companies as zero waste? That is a big part of his business model, because what he does is to supply to industrial installations. This is actually a cement kiln with fuel. They are processing post-consumer plastic waste, making sure that no PVC is in the waste, cutting it to regular small sizes, shapes, so that you easily can blow it, introduce it into the kiln. And everybody makes money, because the cement company gets a very cheap fuel. Still they pay to the waste disposal company for the preparation of the fuel, and the waste disposal company again gets paid to collect the municipal waste and to treat it. So it's a very clean business model for everybody involved. One excursion I definitely would like to make, because it's addressed in the circular economy strategy, that we definitely should look into nature and learn from examples which are there. So nature has millions of solutions found during evolution, which can serve as models for technical solutions also. And in order to inspire us a little bit, I will show a few examples, and then we have a small exercise on this again, because it's best to experience and to experiment a little bit with this idea. It's called biomimikry. Earlier it was called bionics. It's basically the same. Look closely into nature and see what we can learn from birds, from fish, from lions, hunting lions, and so on and so on. Some examples, and then it's your turn. What does this all tell us? owl is hunting mice. The advantage of the owl is you cannot hear it. There is no way of hearing a flying owl. Why is this so? Who knows the secret of... Yes, the concept of the wings, yeah? Yeah. What is noise on a wing? It's vibration, it's turbulence, it's actually a loss in energy, basically, from a technical perspective. It's energy that is transformed not into movement or into lifting power, lifting force, but into turbulence, which causes noise. It's actually a loss. The owl's wing has like fingers, spread feathers, which allow a very laminar flow at the edge. So there's no turbulence, there is no noise, and this is super efficient in terms of energy efficiency. Can we use this in technology somewhere? Do you have an idea? Maybe in fans, yes. This is a picture from Ziel Albeck. They are producing small fans, and they are using exactly this principle with a tented fan blade, which is super efficient, which consumes almost half the energy a regular rigid plate fan would consume. And it's much nicer in a sanitary room because you cannot hear it. Maybe, yeah. You have the experience with the submarines and the sonar. Yeah. Now, so this is one example. Another, a bit sophisticated example is this is a pack of lions, a lion swarm on the hunt. They are looking at the terrain, whether there is animals coming to have some water during sunset, and they are preying on these animals. What can we learn from the hunting lions? In mathematics, in optimization, we have the so-called lion swarm algorithm, who uses the behavior of lions, like spreading out into one nomading lion, more or less, and one settling lion, transforming this into a more or less search algorithm. For optimal, this is an incredibly fast algorithm, which is very stable to find good solutions. And there are similar algorithms which have their strengths in different areas. We don't have to go into this here now. There is a honeybee algorithm who emulates the scouts of honeybees, which go to a terrain and call for the others if they find a potential solution. And then the others come and finalize the area. There is a fish school search where more parallel hunters, more or less, go for a solution, and the one who is first close to an optimum gets the others, and together they finalize the search, and so on and so on. Monkey search is more an erratic algorithm, which branches very quickly, and but search is a quite big area of potential solutions. So this behavior of animals when they look for food was used to develop mathematical search and optimization algorithms. There is quite some literature on this. So these were just two examples for biomimicry. Now we have a worksheet with more examples. And the task for this exercise now is first to look at the pictures. What can we see in these pictures? We again have the owl's wing, we have the lions, and it takes a little bit. Let's look at these pictures. What do we see? Like these very special owl's wing. And for the second column, our task is to find a corresponding technical solution. In the case of the first example, this was the fan blade, the tented fan blade. Now here we have obviously a shark, and this picture is showing the skin of the shark. Can we think of a technical solution which uses the surface of a shark skin? This is a lotus flower. We all know the properties of a lotus flower leaf. Water will not stick. Water will boil off. What is a corresponding solution, and so on. Let's summarize what did we find out. Okay, this we showed already. The shark skin tire profile was used. There were some problems in tires also. I once had a Conti with this profile. It works very nicely, but not in all conditions, because this profile is very difficult to produce, and it clogs, and then it doesn't work so nice. Lotus effect, glass coatings, for example, to prevent water and dirt from sticking. The gecko, this inspired already. Unfortunately, it's expensive, but a special glue, which is really strong, and which you can remove. By shearing, you can take the parts, whereas against tension, it will be very strong. Then what do we have? The lion swarm we discussed at length. The parachute is the usual explanation of the dandelion. The kingfisher is of course about aerodynamics, about hydrodynamics also. So you find it in the Concorde, even in the old airplane with the nose. And this is now the high-speed train in Shanghai. I think it can do more than 400 kilometers per hour, 450 or 410 or 350. Yeah. And this bone-like structure is used in certain cars. Audi is experimenting with such joints in aluminum bodies. On the B column, the joint is a 3D printed part which looks a little bit like a bone, because it actually has only material there where there is a force, and no extra material as you would have in pressed parts or stamped parts and so on. So a little exercise. I mean, this is more to relieve our brains, but I'm sure there would be hundreds of examples we can use at some point, at least to get our imagination flowing. Okay, let's close this again. Restoring nature is also a principle of circular economy. It's explicitly there, and I'm not going at length into this. I'm just showing one example that really impressed me. because if these guys can do it, we also could do it. These pictures are from Ethiopia, where last year, in a single day, they planted 35 million trees. And in Sudan, they did something similar. In Mali, they did something similar, because they want to regain territory from the Sahara, which is moving south. I mean, Ethiopia is not south of it, but it's more east. But this works. They prepared for 3 or 4 years the seedlings, and then in a single day they put millions of trees. And I mean, we'll see whether they survive and whether they are watered and well taken care of. But at least it's possible to do that. In India, they also had a similar activity this year. So if people with very limited resources can do that, why shouldn't we be able to do similar things, yeah? Or at least to take care of our environment?
We do opposite practices
Yeah.
and sell them to Europe.
Yes, we buy a lot of wood from. Yeah, the business model is around IKEA in this case. Now this is definitely something. This deforestation in the Balkans and here in the Eastern Carpathes and so on, this definitely should be stopped to some extent. Okay, now we still need to develop our ideas into a proper business model, because an idea, a returnable cup, something else, is an idea. It's not yet a success in the market. How can we sort of systematically develop all the aspects of a successful business model? And the tool we suggest for this is called the business model canvas. Are you familiar with this approach? Because it's around now. It has been around now for the last few years. Alexander Osterwalder actually is Swiss. He did his PhD thesis at the university in Lausanne. He's from business management, and his ideas are a little bit remodeled here for the application, but they are very valid. And basically, and I have a brief video then, he himself explaining the idea of this business canvas. The basic idea is that you use this canvas really like a canvas. And by using the different segments, you collect all the relevant ideas which from experience make the difference whether the business model works or not. What does the canvas show us? In the first place, the central field is the value proposition of our idea. So in there we put the unique idea, what we actually want to do, what actually shall be beneficial for the client. On the right-hand side is the client. Who is our customer? Brief description, whom we are addressing, because this makes a difference whether we produce something for general market, for a distinct industry, and so on and so on. In between the value and the customer, we have a relationship to build, because we need to link this, and we need a distribution channel. We somehow need to reach out to our customers. This can be different. This can exist, can not exist. We can have to build it. It can be personal communication. It can be Facebook. It can be YouTube. Whatever is a good means of linking the value and the customer. Below, we have the revenue. In which way will this relationship generate revenue, but because these we need, because somehow the model must finance itself. We have here the key activities which we will need to deliver the value we are suggesting. And to deliver these activities, we will need resources. So we put these here. Which activities do we have to perform? Which resources do we need to for these activities? And because, as we have discussed a couple of times today, not all of these activities we will be able to perform. We will need partners. Partners can be a technology provider, can be a logistic company, can be a bank to finance a leasing business model, can be dozens of different shareholders in our business model. And out of the activities, need for resources, need for partners, there will be a demand for costs. So let's listen to the inventor.
So we invented something called the business model canvas. And the business model canvas is like a canvas to paint on. You can describe existing business models, you can describe new business models, you can challenge business models, and ultimately you can use it to invent new business models with the same language. Why the word canvas? Because you can paint out an existing business model or a new business model and make it tangible. So let's look into this. It's about 9 building blocks. The first building block is customer segments. You need to ask yourself, which customers are you serving in your business? Let's look at a newspaper. What are the customer segments of a newspaper? Well, in fact, there are mainly 2. The readers, who want to be informed and entertained, and the advertisers, who want to reach an audience and sell something. So 2 different customer segments with 2 different jobs to be done. And for both segments and both jobs, you will have a different value proposition, a set of products and services that will help the customer get the job done. So once you know who you're targeting and what you're offering, you need to ask yourself, how do these customers want to be reached? Through which channels? Through which channels do they want to communicate with me as a company, as an organization? Through which channels do they want to receive the goods? Is it a physical channel? Is it a digital channel? Are we talking about stores? Are we talking about direct channels? Are we talking about indirect channels? So ask yourself, how does each customer segment want to be reached? The next block is about the customer relationships you establish. So if you're a Swiss private bank, you will have a very personal relationship. A banker will try to build up a very personal relationship with a wealthy family, maybe even over generations. That will have implications on the rest of the business model because it will be people-based, very personal, but not very scalable. If you're Amazon, what do you think? Does Amazon have a personal relationship with us? Well, not personal in the sense of a private bank, but personalized, because they understand our buying behavior and they recommend books to us. So Amazon will have a very automated relationship, but personalized, based on systems, based on computers, based on servers. So very different and much more scalable. Now you could also look at it in a different way. So Steve Blank uses the customer relationships to describe how you get, keep, and grow customers, which is a very important point because customers, you need to acquire them first. And once you have them, you better figure out how you're going to keep them. And if you don't have enough customers, it's not going to work out. So you want to grow. The next question is, what are people or companies that you're serving really willing to pay for? And how Do they want to pay for something that they buy? Do they want to pay a subscription? Are they going to pay a licensing fee? And through which pricing mechanisms? Remember, we mentioned Google? Google is auctioning off their search terms for advertising. They're not just selling them. That makes them much richer than if they would just sell them. So that's the right-hand part of the business model canvas. The part that shows which value you're creating, for whom, and how you're delivering that, and how you're capturing value for yourself as an organization. Now we want to look at the left-hand side of the canvas, where we ask ourselves, how are we going to do it? What do we need to create value? The first question is, which resources do I really need to create value? Do I need factories? Do I need a brand? Do I need intellectual property? Do I need servers? What are the key things that you need to have to create that value that you're promising on the right-hand side? And then the next question is, well, we know what we need to have, but what is it that we really need to do, that we really need to be good at in our business model? Which activities do we need to excel at? Is it marketing and sales? Is it research and development? Is it managing servers? What are those activities that are crucial in our business model? You want to ask yourself, in addition to suppliers, who are the key partners that can leverage your business model, that can turn your business model into something more powerful? So an interesting example here is the social gaming company Zynga, which built their entire business model, or a big chunk of it, on the back of Facebook, which became a partnership. And probably Zynga couldn't have scaled so quickly without using Facebook as a partner. Now, if you know all those three elements on the left-hand side of your canvas, very quickly you can sketch out what your core costs are. And then you have a big picture understanding of the logic of your business. All the pieces that you need to create, deliver, and capture value. All those elements that are important to succeed in business. Now, that's just a concept. Let's turn it into a real tool that we can use in our everyday work, where it really becomes a canvas on which we can paint out our business model. And I use sticky notes, or a new tool called Studies, to map out business models. That's very powerful because you will make it tangible. Ask yourself, what are or who are the customers? Sticky note. Well, if those are the customers, what value am I offering them? Sticky note. How am I reaching my customers? Sticky note. Oh, if that's the value I'm creating, that's the way I'm delivering it, well, what resources do I need? Sticky note. What activities do I need? Sticky note. So you can map out your entire business model, the business model you want to create or the business model that you already have. It will give you a clear picture and a better understanding of all the pieces of your business model.
Okay, now everything clear about how to build a business model, how to become successful. I mean, it's a model. It doesn't contain yet all the ingredients, all the spices, all the magic potion it needs to really develop something successful. But as a model, it's very useful. Now let's describe our business model. You have a template, you have the business canvas in front of you. Again, let's work in groups and let's put up a successful business model for our returnable cups. So this is just, but this is in your materials then. Because we tried this exercise in the office and this is the result, more or less. Basically, as all of us go to events every now and then, the client is very broad defined here. It's basically everybody. The customer relationship from our perspective is quite easy because people will want something to drink. So we have to talk to the shop owner, restaurant keeper, caterer, whoever is providing the drinks, and actually to establish a link to these people. We also need to find channels which are basically the ones who organize the events. Because if they tell the caterer, you have to do that, then we are in business. And this is actually how the model is working now, mostly in Austria, because in all these big events, public viewings, the Donauinsel Festival, the Christmas market in Vienna, basically in the background is the city of Vienna, just if you look at Greater Vienna. And Vienna has it as a principle now, only returnable cups, full stop. It took a while to convince them. Now they are convinced, and now everybody is in business who can provide the cups. You need to establish almost a network of companies, because you will not want yourself to invest into a washing machine, to buy a truck, to get people, because all this is there. The caterers are there, the washing installation is there, the logistic companies are there. You simply need to talk to them and to make sure from an organizational point of view that the cups are there before the event, that they will be collected after the event, and so on. So you just need to think through the whole operation and organize it, basically. You will find all the elements to combine. And then basically, of course, revenue is, we would ask the caterer for a fair share of what they are selling. And cost structure, we could calculate how much staff, what the contracts will cost, how much they charge for washing the cups, and so on and so on. So this would be a quick overview. A few ideas how not only we, but other more intelligent people think that the future of manufacturing will look like. This is borrowed from University of Cambridge. This Professor Evans there. So he puts it in a pointed way, how he thinks manufacturing will look like in the future. He says lean and clean, okay. This is what we were always talking about, high efficiency, eco-efficiency, and so on. Then he says never can say goodbye to materials. So thinking in closed loops only, no other business models possible. What we had a couple of times today, knowing me, knowing you really have to know your suppliers, your clients, and so on. This is also where we could link to big data, to industry 4.0 and so on, how these data come to us, how we analyze the data, how we classify, how we do statistics and so on. Kissing frogs. Entering into new collaborations, which we maybe would not have thought before, is part of many business models. Keeping in touch means establishing close contacts to the clients, to the customers. This also includes tasting, a lot of experiments, finding a small market, tasting a new product. If it's fine, upscaling. If it's not fine, changing. Make it anywhere, local making, regional thinking, regional resources are a big part of the game. Also this prosumer thinking could be a stone in this pattern to make the things there where they are needed, maybe even by people themselves, by the clients themselves. Slow making, provenance, high value is logical somehow. Not going for the mass market, but for the specific one where the readiness to pay is there. Circular vision. This is borrowed from the European Commission now. just to summarize, the vision is that establishing more and more circular business models can have the following effects. There are studies which project that you can have 30% more GDP per ton of mass which you use in the economy on a European level. For individual macroeconomics, this even can have a higher leverage effect. Materials use more than 70% at least, so much more recycling than today. You remember these numbers, 8%, 9%, 12%, and less than 5% of materials going to landfill. And ideally, that's why they put these scissors here. Ideally, for the far, far future, cut off this part completely. So ideally, no landfilling, no waste, everything is used in the cycle as a vision. Barriers, we are not going into these details now. It's clear that these business models will face walls sometimes, which need to be brought down brick by brick. Because people are always asking, what can we do immediately? Some suggestions. Let's think of the examples which we discussed today. What can everyone, every company do immediately is to optimize their use of material as much as possible. Like cutting patterns, like whatever is a waste should be questioned. Separate reuse, sale, production waste. Basically, at least in the next few years, there will be a market for everything. If we look, we even find it today already. Have a close look at auxiliary materials, all these lubricants, cutting lubricants, hydraulic fluids, and so on, because they generate a significant amount of waste, and they are sometimes overlooked. But we could discuss this in detail. Replace hydraulic systems by electric systems. Think about cutting, about acids, about caustics, and so on. Save energy. This is a common feature of all the concepts. Energy is cheap, but it's not not as easily available without the price as we think. Use low carbon energy sources. Low carbon economy is also part of this. We did not discuss this in detail. What should go on your agenda for the years to come? Select materials carefully. I think this is a lesson learned, I mean, not only from today. We need to know what we are working with. We need to cut out everything that is toxic or causing problems in recycling and so on. Recycle production waste. Basically from production there should not be waste. If companies cooperate, call it industrial ecology, call it industrial symbiosis, whatever. If there is an exchange of materials, we think about this Krauss-Maffei example, waste from production can be minimized. Now comes this big data, industry 4.0 and so on. Use sensors, the right sensors in the right places, know how to read them, use the data, evaluate the data, build optimization models based on data, not on emotions about the process, but on hard data. We do have the means today to collect data and to use data. Something tricky, something where we are learning now, prepare to take back products, because this will be the future. The products will not end up in the landfill, but in our companies, and we need to be prepared what to do with them. Design resource-efficient products, consider new business models, like our last exercise. Prepare that maybe sometimes we will kiss frogs in order to establish the cooperations it will take to be successful in the future. not discussing this. I think the message is clear. The waste bins actually are gold if we use them properly. There are sources in the presentation you might want to have a look at. European Commission has a wealth of information. They have all the laws, bylaws, evaluations, working documents for staff. All this is public, and sometimes good to learn. Ellen MacArthur Foundation has very nice pictures, very good approaches in effectively presenting the idea. UNIDO puts more and more materials on their webpage. If you are interested in repairing, in remolding, there is a wealth even on YouTube. So instead of watching silly movies, maybe you can spend. So thank you for your attention. If we made any mistakes regarding not quoting sources correctly, I apologize. We will correct. No copyright infringements intended. Yeah, sometimes this is an issue today. Okay, thank you very much for your attention. Let's go circular.